Find the Taylor series for function f centered at 3. That's the center, a equals 3. If nth derivative of the function at 3 is given by this formula. We know that Taylor series for a function is given by sigma, it's the sum n from 0 through infinity of nth derivative of the function at the center divided by n factorial x minus a to the n. So this is the formula, and our center is 3, so let's do that. Basically I'm replacing center a by 3, x minus 3 to the n. Now in the question fn3, so this part is fn, that's the nth derivative of the function at 3. So we replace this by this, then we get sum n from 0 through infinity. So this numerator is negative 1 to the n factorial all over 2 raised to n plus 1, and we do have n factorial on the bottom, times x minus center raised to n. Now we can simplify n factorial and done. Pretty much there is not much to do. Now we can just write the final answer. Negative 1 to the n, 2 to the n, maybe we can combine these two. So negative 1/2 raised to n, that's optional kind of, 1 over n plus 1, that's on the bottom, and x minus 3 raised to n. So this is it, the Taylor series for f if the nth derivative is given. Now if we want to find the radius of convergence, we can do that. Radius of convergence, because this series makes sense inside from 3 through some radius. Okay, outside maybe, I don't know, if radius is 2, then 3 plus 2 5, 3 minus 2 1. This makes sense inside 1 5. So let's find the radius. We know the center 3. So to find the radius of convergence by an application of the ratio test, we can use, just find the radius in this way. It's kind of the reciprocal, so a n over a n plus 1. Okay, which is in this case limit n going to infinity of an means whatever we have here, that's an plus 1 means just replace n by n plus 1. So an on the top, so negative 1/2 raised to n 1 over n plus 1 divided by an plus 1. So same thing, but n is now n plus 1. Negative 1/2 raised to n plus 1. I don't have room there, so let me put on the bottom. Okay, divided by negative 1/2 raised to n plus 1 times 1 over n is n plus 1 plus 1, n plus 2. Okay, so let's find this. Okay, this is reciprocal of the ratio test. In the ratio test we did an plus 1 over an, but I'm just finding the radius of convergence. So this works. Limit n going to infinity of, when we take absolute value, this negative signs just become positive. Okay, negative 1 to the n, when we take absolute value, just positive 1. Okay, so that's 1 raised to n over 2 raised to n. So let me simplify and we get answer in next line. So I got, and I'm getting rid of absolute value. So this is pretty much 1 over 2n. 1n is 1, 2n times 1 over n plus 1. and I want to change this division into multiplication, so I need to flip. So this 2 raised to n plus 1 goes on the top, over -1 is positive, so just 1, and this fraction n plus 2 goes to the top as well. Okay, and we know that 2 raised to n plus 1 is 2 raised to n times 2 raised to 1, or just 2. So 2 raised to n, 2 raised to n cancel, so 2 survives there. So this limit is limit n going to infinity of, there is a 2 n plus 2, 2 n plus 2 over n plus 1. Okay, and when n goes to infinity, limit at infinity, n plus 2, n plus 1, leading terms matter, so just 1, so this 2 can be pulled outside, so 2 times 1, so the limit is 2. That means the ratio, from an application of ratio test, we can find the radius of convergence is 2, center 3, and radius is just 2.